All right, I think we're going to go ahead and get started. Thanks for coming to reInvent, and thanks for coming to the talk today. The name of the talk is Integrate Social Login into Mobile Apps. My name is Bob-Kinney. I'm a software development engineer with the AWS Mobile team. Our goal with the AWS Mobile team is to build tools and services to help developers build great mobile apps. So our agenda for today is we'll talk a little bit about the AWS Mobile team and sort of what the tools and solutions that we provide. Then we'll jump right into why we're here today, which is a solution called Web Identity Federation. And we'll talk about some other options on top of that for integrating login into your apps. So for AWS Mobile, what you're seeing on the screen right now is just a small selection of the tools and service that we have available for mobile developers. So these are some of the things that are going to be in an app that I'll show a little bit later. We're obviously focusing today on social login, but we also offer file storage with Amazon Simple Storage Service, or S3. We have online data access with Amazon DynamoDB, and we also have mobile push integrated with Amazon Simple Notification Service. So the best place to get started with the AWS Mobile platform is our Mobile Development Center, which is aws.amazon.com/mobile. From there, you'll find links to our AWS Mobile SDKs, the Amazon SNS Mobile Push documentation, our Geo library for Amazon DynamoDB, our S3 Transfer Manager, and we're constantly adding new features and solutions all the time. So why are we here today? If you're already developing apps for mobile apps that integrate with AWS, you're familiar that when you want to send requests to AWS, we have to sign those requests. And in order to sign those requests, we need an access and secret key. Now, you might think that the first thing you would do is embed those credentials inside of your application so that you can then make requests to AWS. That will certainly work, but the problem is that there are plenty of tools out there for a user to crack your app, take a look at what's inside, and actually extract those credentials out. And once those credentials have been exposed, a nefarious user can use those credentials to do anything that the policy for those credentials allows. So you might think, I'll use an IAM user, and I'll set a policy on it, and then I'll restrict that policy to only those resources that are available for the app. And that's certainly a great solution. That will solve the problem of exposing too much with the root credentials, but then you have a problem where you're no longer able to rotate those credentials. Rotating the credentials would require you to actually push out a new version of your app, which can lead to some lag time. Can't guarantee that the users will actually install that new version, and there's also a lag time with certain of the app stores. So what do we really want? We want to get credentials on the device so we can make those calls to AWS services. We want to limit the lifetime so that we can enforce rotation of those credentials. We want to limit access of those credentials to only those resources that the end user of the application should have. And we think the solution to this problem is a product called Web Identity Federation. So what is Web Identity Federation? At its most basic level, what Web Identity Federation allows us to do is take credentials from an identity provider, such as Google, Facebook, or login with Amazon, and trade those credentials directly for AWS temporary credentials. Now, the best thing about Web Identity Federation is we can do all of this without any back-end infrastructure. So now what I would like to do is show an application that uses Web Identity Federation. Now this application, you'll notice, is obviously built in iOS, but all of this same technology is all available on Android. Nothing that is in this application cannot be also implemented on that platform. So when I first bring up the application, you can see I'm prompted with a login button. So I'm going to go ahead and click that. And that's actually going to bring up a number of providers. I'm going to go ahead and click on Facebook. And that's going to redirect me to the mobile browser. I've already authenticated in the mobile browser with Facebook, so now I'm just confirming that I've already authorized this application to access my Facebook information. I'll click OK. I'm redirected back into the application, and now I have a session not only with Facebook, but with AWS as well. I can click on the Show Pictures button. Let's make this a little smaller so we can get it on the screen. Okay, so if I'm on the Personal tab, you see I don't have any pictures, personal pictures there, but if I click on the Public tab, I can see some pictures that have been uploaded by other users inside of the application. I can click on them and view them. I can add a favorite, and then if I go over to the Favorites tab, it'll show up there. And then I can also add a picture. So I'm going to go ahead and select a picture from my photo roll. I'm going to choose this one with me with former Bruins goalie Tim Thomas. And I'm going to make this photo private to me. I'm going to go ahead and submit it, which will upload. And I get notification that the photo has been uploaded. Now if I go back to the Show Pictures screen, I now see that this photo is available in my personal pictures and it will download. Now if I log out and re-click the Login button, and instead of choosing Facebook, I try to choose one of these other ones, I get an error that the provider has not been implemented in this application. And the same thing with Amazon. And what we'll do today is we'll actually add Amazon support to this application in the session. So what you see here is an architecture diagram of the mobile photo share application overall. So we have integration with the S3 Transfer Manager for downloading and uploading photos. We're using the Geo library for maps, which I failed to show. And then also we're using the AWS mobile SDKs for actually storing those favorites in a table in DynamoDB. Now obviously today we're going to be focusing on the login aspect of this. If you're interested in learning more about the rest of the application, I would highly recommend that you seek out the slides and the video when they're posted for the MBL 402 talk, which was given by my colleague Glenn Dirkus. So he goes into depth with all of those other parts of the application. So now I just want to walk through the actual auth flow for a Web Identity Federation session. The first thing that happens is our mobile client will authenticate with our identity provider. In our original demo, we obviously were using Facebook. After we've actually authenticated with Facebook, we get back what's called an access token. And that is what uniquely identifies our session with the identity provider. We authenticate with the AWS Secure Token Service, which is a feature of IAM, Identity and Access Management. And then on the back end, STS validates that that token is valid for the application. And if it's valid, STS will then return us temporary AWS credentials, which we then can use to access our resources, such as our S3 bucket. So what do we need to get started with Web Identity Federation? Well, on top of the AWS mobile SDKs, which actually handles the communication with STS, we need an application with our identity provider. We're going to do login with Amazon. We need an AWS IAM Role for Web Identity Federation. And then we need an SDK with the identity provider in order to glue everything together. So as I mentioned, we're going to do login with Amazon today. So if you go to login.amazon.com, you'll be able to log in, get started, and create an application for allowing your users to log in with their their Amazon credentials. The benefits here is that obviously Amazon has millions of customers, and there's lots of information that you can use to customize your application's experience for the information that's in the account. Login with Amazon is based on OAuth 2, which is an industry standard for login. And there are SDKs available for iOS, Android, and the web via JavaScript. So now what I'll do is actually go out and create a application with login with Amazon. So I'll switch to my web browser, which is already on login.amazon.com. And then I'm going to go to the app console. Now I already have an application here, but I'm going to go ahead and click on Register New Application to create a new one. I'm going to call it Mobile Photo Share. And just give it a quick description. For the privacy notice, I'm going to leave in a filler, which is just the AWS homepage. Now this will actually be displayed to the user when they log in, so you want to make sure that you actually fill it out or put in your actual privacy policy URL, because the users will see that. I'll go ahead and click Save and skip adding a logo. And now I have an application with Login with Amazon. And one of the important things to note here is our app ID. This is what is going to uniquely identify this application with Login with Amazon. We'll need this later when we integrate with the role. While I'm here, I'm going to go ahead and create my iOS settings for Login with Amazon. And I'm just going to give that a label, and then I need to provide the bundle ID, which is going to be the bundle of our application. In our case, that's com.amazon.aws.mobile photo share. Now that I've saved my login settings, I have this get API key value. And when I click that, I get the key that I need to use to identify myself with Login with Amazon. So we'll need that information as well later. So that's it. I've now created my application with Login with Amazon. So now that we have our application with Login with Amazon, our next step is to get our AWS IAM Role for Web Identity Federation. If you're not familiar with AWS IAM Roles, it's a mechanism for delivering temporary credentials to any number of different kinds of services. There are two policies that are associated with a role. We have our trust policy, which is who can assume that role, and then we have our access policy, which is exactly what you might expect it would be. It defines what resources the role can access once the role has been assumed. There are three basic types of roles. There's AWS service roles, such as for EC2. We have cross-account access roles for either cross AWS account access or for enterprise federated logins. Finally, we have the ones that we are going to use today, which is Web Identity Federation roles. Now, for a role with Web Identity Federation, our trust policy is going to basically be based on two things: what identity provider we want to trust, and what application inside of that identity provider we want to trust. So all users of that app for that provider will be able to log in. And in our access policy, again, exactly what we expect. We want to make sure that we only give the resources, access to the resources we need for our application. So now I'll break out and go to the AWS console and go to the IAM tab. Go to roles, and there's a number of roles already in here, but I'm going to go ahead and create a new role. I'm going to call it Mobile Photo Share Role. I'm going to select Role for Identity Provider Access, and then we're going to select Web Identity Providers. I'm going to select my identity provider, which is going to be Login with Amazon, and then I'm going to switch back to grab my app ID. I'll paste that in, and I can review the trust policy here to see exactly what the JSON policy is that we're generating for our wizard. We can see that we're allowing this assume role with web identity action, and we're allowing our application to log in. I'll go ahead and click continue. And I'm just going to go ahead and click select a custom policy. I have a pre-built policy here, which is actually a little bit wider than it needs to be, but we'll fix that later. And then I'm going to go ahead and click create role. Now, if I bring that role up in the summary tab, the important thing to note here is our ARN. And this is what uniquely identifies our role inside of AWS. We'll need this information as well to integrate with our app. So that's it. We've now created our role for Web Identity Federation. So we've created our app, we've created our role. So the final piece of the puzzle is to get that SDK and then glue everything together. As I mentioned before, Login with Amazon has SDKs for iOS, Android, and JavaScript. Obviously, we're going to be using the iOS version today. So we just need to download the SDK, add the necessary files to our project, and then we integrate it into our app. And the two pieces of information that we really need here are our API key from the Login with Amazon portal and our AWS IAM Role ARN that we got from the AWS console. So now, I'm going to jump out and go to Xcode and actually add Login with Amazon to our application. So I already have the Login with Amazon SDK downloaded on my device, or on my laptop. I'm going to take the universal build because I'm building for a simulator. I'm just going to drag those files directly into my application. I'm going to go to my plist. And I'm going to add a key called API key. And then I need to get my API key from the console here for Login with Amazon. So I'm going to go ahead and copy that out, paste it in. And then we took a little bit of a shortcut here. Let me make that a little bigger. Now, we took a little bit of a shortcut, and we added some code already to integrate with Login with Amazon in our application. So all I really need to do here is add, change a couple of constants that will drive some preprocessor definitions. So I'm going to enable Login with Amazon, which allows us to import the necessary headers. And then I just need to add our role ARN, which we can get from the AWS console. Just copy that. Paste it in. And that's really all that's necessary for this application. Now, we would obviously need to add some code and callbacks, but for our purposes, if we just run our application now, start a new instance of the simulator, which hopefully will not take very long to show up. And here we go. So now when I click on Login and I click on Amazon, this time instead of the Facebook page, I'm going to redirect it to a mobile version of the Amazon login page. I'm going to go ahead and log in. And I'm going to get my password. And as I mentioned, you can see here the privacy notice link comes up. So if a user clicked on that, they would get redirected, in this case, to the AWS homepage. So I'm going to click on Agree to allow the app to have access. It'll redirect me back to the application. And now instead of a Facebook session, I now have a Login with Amazon session. But I am also have a session with our app with AWS. Now, if I click on Show Pictures, I'm not going to see any pictures. It's important to note that there's a distinction here where my Facebook account is seen from Web Identity Federation as a completely separate user from my Login with Amazon user. So then the photos and all the other settings are going to be distinct between the two providers. So I can see the public photos. I can add a favorite, and then see that favorite show up there. I can then also upload a new picture. This time I'll choose my photo with Jared Saltalamacchia of the Red Sox. And I'll upload that photo as a public photo. Now when I click on Show Pictures, oh, I left it as private. All right, so you can see that I have that picture available again. So now I have that, it shows up in my personal photos. So that's great. We've now integrated Login with Amazon inside of our application. So just to summarize, we started out with our AWS mobile SDKs for integrating and accessing all of our services. We created an application with Login with Amazon to authenticate our users. We created an IAM role that allows us to federate that access with that application to our resources that we need. And then we downloaded an SDK to kind of glue everything together for authentication. So now I'd just like to revisit the Auth Flow. This time specifically looking at the resources and identifiers that we use with Login with Amazon. So when we authenticate with Login with Amazon, we're going to use that API key. That's how we uniquely identify ourselves with Login with Amazon and ties to our app. When the user logs in, we get an access token back. Once we have that access token, we pass that to AWS STS along with the ARN for our role. STS validates that token with the identity provider and then verifies that it matches the app ID that we put in our trust policy. Assuming all of that is all valid, we get our AWS credentials back to the device. And then we can access resources inside of our bucket, and we pass our user ID as a prefix so that we restrict access to only our photos. So our personal photos are in a subfolder, so to speak, inside of our bucket. However, I noted earlier that our access policy that we put on our role was a little bit too wide. So while we actually are restricting access to the photos inside of the application, if somebody actually got those credentials out of the device, they would actually have more access than what we want. So all I'm going to do is actually demonstrate what that actually means. So inside of my app, I'm going to go to my picture list view controller. And here in the code, we have a block that creates a prefix based on whether or not we're looking at public or private photos. For our private photos, we're looking at just the user ID prefix. For public photos, we're looking for /public/user ID. So if I actually comment this line out, now when I click on the personal tab, I'm actually going to list the entire contents of the bucket, not just the prefix for my user. I'm going to go ahead and recompile the app and launch it. So now you'll notice, again, when I launch and I get to the personal tab, I see that Tim Thomas photo that I added with my Facebook user. That was private. That was not something that I, as my Facebook user, wanted to share with other users. but these credentials actually have access to actually download that file. So obviously we want to try to correct that. So what you see on the screen now are basically the 3 statements that were in the policy that I used to originally create my role. There's a lot of stars in there. We're giving access to all the resources and all the actions for the services. So you think, your first thought might be, first thing we'll do is obviously restrict access to only those actions and those resources that we would need for our application. So we can definitely do that. We can restrict access to those actions necessary for the S3 transfer manager to operate on our bucket, and only those actions that are necessary to actually store inside of our table with DynamoDB, and also to register for push notifications. This is great. This is a great first step. Obviously, I don't have access to other S3 resources, but I still have global access to the bucket. So it doesn't really solve the problem that we saw in the application. So for S3, our next step might be to add a specific prefix condition to our policy. So we can add a /my name. So now, when I log in, I'll only have access to my photos. The problem here is that the policy on the role is applied to every user who assumes it. So now anybody who assumes a role with this policy would have access to my photos and not their own. So that doesn't really solve our problem. So how do we get this prefix condition, but also a policy that will be applicable to all users who log into our application? And the answer to that is policy variables. For Web Identity Federation, there are basically 2 classes of policy variable. One which will identify the application ID, and one that will identify the user inside of the application. So for login with Amazon, we have this www.amazon.com:user-ID, and that will be the user identifier for our application, or for our user who logs in with login with Amazon. So now that we have these policy variables, we can substitute my name with that variable, and now any user who logs in will only have access to the resources in their prefix. So for personal photos, we have the prefix that is their username, and then we also want to be able to list the items in the bucket, and then we also need to be able to have some basic operations with multi-part uploads for the S3 transfer manager. For our public photos, as I mentioned, everything is under a public prefix, so we need to give read access to everything under that prefix, and then we need to allow for write and delete operations in the subfolder under that prefix. Finally, we need to be able to list those photos, so that's what that last statement is for. For our DynamoDB policy, we recently launched fine-grained access control for DynamoDB. So now we can actually restrict access to a specific hash key or a subset of columns inside of a table. And using policy variables with login with Amazon, we can basically ensure that the user only has access to their entry in the favorites table. So now what I'll do is actually go back and correct the permissions on our role so that we properly restrict what resources the user has access to. So I have here the policy, which has all of the statements that I showed on the screen, just in a slightly different order. I'm going to go ahead and copy that. I'm going to go back to the AWS console, go to the Permissions tab, Manage Policy, and paste this new policy in. I'm going to stop the application and restart it, which will initiate a new session with STS to get new credentials, which will pick up that new policy. And now when I click on Show Pictures, I get an exception. Great. Well, what we should have seen there is an error that should have popped up. So, I mean, obviously, we're getting somewhat of the correct experience in the sense that the application is no longer able to access the resources it doesn't have, it shouldn't. So if I go ahead and reset this prefix, now click on Show Pictures, I now only see my pictures, and I only have permission to do that. I can still see the private pictures. I can still see my favorites, and these are the only resources that I actually have access to. So now that we have a correct policy in place, the user gets what they need, but they don't get anything that they shouldn't have if they manage to extract the credentials from the application. So that's Web Identity Federation. Just to summarize, we have 3 supported providers, Facebook, Google, and Login with Amazon. We use IAM Roles to provide the access restrictions, to define which applications with the identity provider we allow login access for. And then we use policy variables to give that per user level access, policy restrictions like we saw on the mobile photo share. So that's great. We have a solution for those 3 identity providers. But what if our user base doesn't use one of those identity providers, or they don't want to, or we want to support a private pool of users? We actually have a solution to this problem. It's a slightly older solution. It's called the Identity Token Vending Machine. And unlike Web Identity Federation, the Token Vending Machine has a server and client component. The server code is designed to, the sample server code is designed to be deployed in something like Elastic Beanstalk. And then we have client code that runs on the device, both iOS and Android. And so what happens is that the iPhone register, or the device, sorry, the mobile device registers through a mobile web browser. And that will store a record inside of DynamoDB. Once we have a record for a user inside of the TVM client can log in. That will return an encrypted private key that will then be used to sign the request to get token. On the back end, the TVM calls AWS STS to generate a time-locked and restricted token. Once it gets that token back from the service, it returns it to the mobile device. And at that point, we can then access any services that are defined in our policy inside of the TVM. So just a little bit about policies with TVM. At your most basic level, the most privileged credentials have access to everything inside of your AWS account. Our recommendation for deploying the TVM is to actually use an IAM user with a restricted policy. And that policy should be the restriction to only those resources necessary for your application, plus those necessary to actually run the TVM. So that would be our app bucket, our bucket for our pictures, our DynamoDB table for our favorites, the DynamoDB table for the TVM itself, push notifications, and STS. Once we have that policy, there's actually another policy that is applied on the generated credentials with STS. And those credentials should slice out those resources not necessary for the application. So those would be the things that would be necessary for the TVM to run. So we don't want the app to have access to our TVM table, and we don't want it to have access to call STS on its own. So we just remove those from the policy that is applied on the credentials by the TVM. The identity TVM code, the server code is available in our AWS Labs repositories. And then our client code we have in multiple samples for both iOS and Android, and those are also on GitHub. These are provided as sample implementations. They handle most of the logic that you need, but they should be customized to meet your needs. That includes the policies associated with that to make sure that you actually have the policies that match your use case. So what about anonymous access? It's getting far more and more common for a mobile application to present such screens such as this when you first open the app. You're prompted to log in or register. But what am I getting when I log in? What if we could offer a preview to entice our users into looking into the application so that they know what they're going to get before they log in, and they will actually create an account? How do we provide that level of access in our application? We don't have a login with an identity provider to use Web Identity Federation. We don't have a login, a user session associated with the user to use the identity TVM. So how do we do it? Well, we have another solution here, and it's an anonymous token vending machine. And much like the identity token vending machine, there's a server and a client-side component. But instead of registering a user, we register a device with the token vending machine, which stores a record in DynamoDB. And then after that, we can call getToken, which makes a call to STS to generate our temporary credentials, which is returned to the device, which we then can access resources with. Now, policies for the TVM, recommendation that we make is that you use read-only policies for these resources, because we have no way of identifying an abusive user. We don't want to necessarily allow them to upload photos, but we would like them to be able to see public photos that have been shared by other users. So now I'm actually going to demonstrate the anonymous access that's built into the mobile photo share app. So if I go back to the mobile photo share app and I click log out, I'm now in an anonymous session. So my add picture button has gone away, but I still have show pictures and picture map. So I can click on show pictures, and I can still see the photos that have been marked as public. I no longer have the ability to add a favorite because I don't have a user session associated with it. Additionally, I can see all public photos on a map. So let's see how that's actually implemented. So in our mobile photo share application, we actually have an additional project, which is our TVM client code. And we actually implemented a credentials provider that adheres to our AWS or Amazon credential provider protocol for the iOS SDK. This protocol basically has two methods that need to be implemented. One, which is credentials, which actually delivers the temporary credentials to the service clients, and refresh, which ensures that the temporary credentials are recycled on a regular schedule. So in our refresh, we actually go out and make the calls to the TVM to get the token and store that response locally, and then refresh on an as-needed basis. And all this code will be available after the talk as well. As with the identity TVM, the anonymous TVM server code is available in a GitHub repository in our AWS Labs org. The client code is integrated in a number of samples in both our iOS and Android samples repositories. And again, it's provided as a sample implementation and can and should be modified to meet your use cases. So to sum it up, if the user has a Facebook, Google, or Amazon account, we can use Web Identity Federation. If the user has some other form of account or a private pool of users, we can use an identity TVM. And if the user has no account, we can use the anonymous TVM. As I mentioned, the code for the mobile photo share application is available on GitHub. In the repository is the iOS application that I demonstrated, and then also a back-end infrastructure which can be deployed in Beanstalk, which is actually a bundle of the geo server, the identity TVM, and the anonymous TVM. Also in the repo are instructions for actually deploying it yourself, so you can test it out in your own account. If you're interested in learning more about Web Identity Federation, the IAM team actually put together the Web Identity Federation Playground. This is an in-browser Web Identity Federation application. So you can actually see the responses and the actual raw requests and responses to both the identity providers and STS itself, and see what those calls look like and the returning results. So you can see the information for yourself firsthand. This is actually implemented in JavaScript. And if you were paying attention recently at the keynote, Werner was actually mentioning our JavaScript SDK, our JavaScript browser SDK. Web Identity Federation also works with that as well. For the AWS mobile SDKs, the best place to get started is that mobile development center I mentioned at the very beginning, aws.amazon.com/mobile, and then the sample repositories that I've mentioned before as well. Those samples have examples of how to use various services from a mobile device, and then also specific use cases like sending feedback from a form or doing a message board with SNS and SQS. Finally, if you need assistance with either using the mobile SDKs, Web Identity Federation, or any of the things that I talked about today, we have our mobile development forum at forums.amazon.com, aws.amazon.com, and then we also monitor Stack Overflow. So any questions tagged with Amazon Web Services will be monitored by AWS employees, and if it doesn't receive an answer from the community first, we will follow up on those questions. If you're interested in talking more after the session, if you don't get your questions answered, we're actually going to have mobile office hours today from 4:30 to 5 and tomorrow from 9 to 10. We'll also just be around in the booth if you can't make one of those specific office hours. We also have a mobile blog where we actually post best practices and tips and tricks for using the AWS mobile SDKs, and that's at mobile.awsblog.com. And then finally, we actually recently started a Twitter account for the mobile SDKs at AWS for Mobile. So that's my talk for today. I appreciate everybody coming out. Amazon takes customer feedback very seriously, so we would ask that you actually fill out an evaluation form for this talk that will help not only me be a better presenter, but help us provide content for you in the future. As a thank you, we're actually going to be giving away prizes for filled out evaluations, so make sure you fill that out as soon as possible. Just as a reminder, the section is SEC401. So at this time, I'll open the floor to questions. I would just ask